All right, and we're going to continue our work with quadratics, and we're going to shift gears. So the first two lessons was solving, all right, graphically, and then what we're going to spend the next two lessons on, all right, is solving quadratics analytically, which means with equations. And we're going to talk about two different ways. And so today is going to be factoring, and the next lesson will be quadratic formula. Now, so that means the good news about today's lesson is like 90% of it you already know. So there's just a couple small details we have to add. All right, so to get you thinking about factoring, we have our opener. So we have two problems here. So what I would like you to do is go ahead and pause the video, factor those problems, turn it back on, and let's see what you remember about factoring. All right, so here's my work. So remember the first step, that you want to look for a GCF. You may not have one, but you always want to look for one, all right, before you begin the problem. So now when I look at A, all right, there is not a GCF. All right, so I can go right into my area model. And remember what we talked about. The first term goes in the first box, the last term or the C term goes in the last box. All right, and then what we know about the two terms here on this diagonal that we're looking for is that they have to multiply to be negative 24 in this case, and they always have to add to be our B term. So you can see my two terms would be 24x and negative 1x. And once again, it doesn't matter which box you put those in, and then you just go through and find your GCF like I did here. And so you should have 8x minus 1 times x plus 3, or vice versa. Remember, the order doesn't matter. Now, notice on B here. All right, so when you look at this problem, there is a GCF. So I can take a 4 right out of every term. So I want to factor that 4 out. And notice what that does for me. That gives me the quadratic 9x squared minus 3x minus 2. So that reduces my choices, all right, when I'm going to look at my combinations here. So now 9x squared is my new A term, and it goes in the upper left. Negative 2 is my new C term, it goes in the lower right. And notice that makes a difference because now I have to multiply to be negative 18 and add to be negative 3 there. All right, notice that's much different than having to multiply to be 36 times negative 8, whatever that is, right? So nearly 300. All right, so, all right, and then once again, all right, then you go through your combinations, look for your GCF, and you should get 3x minus 2, 3x plus 1 in either order. And then remember, whenever you factor a GCF out, we want to bring that down. Okay, now, so how does that tie into solving? All right, so when we look at solving, all right, we know from all the work we've done this year that the equation has to be equal to 0 when you solve. All right, so we've talked about that. It has to be equal to 0. Now, if you look at what happens, if we have something in factored form, all right, equal to 0, this is a multiplication problem. All right, so something times something is equal to 0. So if that is true, now we can use the 0 property for multiplication. We've been using the 0 property for addition and subtraction a lot this year. All right, now the 0 property for multiplication means, all right, one or both of these guys should be 0, right? So something times 0 gives me 0, or 0 times 0 gives me 0. So once I get it in a factored form, what that means is I can take each factor and I can set each of those factors equal to 0 and solve, and these are the problems we've been solving all year. All right, so that's what we want to get to. All right, now sometimes what that means is it starts in standard form. So it's going to look like it does in the opener up here, okay? And if it looks like that, what we have to do then is factor it to get it into this form, and then we can use our 0 property. Now, if it's in vertex form, we've already know how to solve, right? We've done that problem a lot this year, okay? So if it's in factored form, right, we know how to solve that one. We just go through our process, all right, and our normal solving, and we'll do a couple of those examples to refresh your memory as well. All right, so let's go ahead and look at some problems in factored form. Now, we went ahead and gave you a few examples here, and notice these have 3 things equal to 0, all right? So it doesn't matter how many things are multiplied to be 0, we take each one of them and set them equal to 0, because any of those choices could be 0, or all of them could be 0. So notice, take my first thing here, this means x could be 0. This means x minus 3 could be 0. This means x minus 7 could be 0. And then I solve each of those pieces. Now, this one's already solved, so x equals 0. When I solve this guy, right, this is the 0 property for addition and subtraction, so we know x has to be 3 because 3 minus 3 is 0. And the same thing here, we know x has to be 7. All right, so there are my 3 solutions, or 3 intercepts. All right, if we think about x-intercepts, because if y is equal to 0, all right, that's where it crosses the x-axis. Those are my x-intercepts. All right, looking at number 2 here. Once again, we have 3 pieces. It's equal to 0. So we just take each of those pieces and we set them equal to 0. And then we solve each of those individual pieces. All right, so once again, here's that 0 property that we've been talking about all year. So x is equal to negative 2. X is equal to 4. x is equal to -5. So when it's in factored form, it's already in factored form, it's a pretty simple problem, right? We just use the fact that anything could be equal to 0, all right, in this multiplication problem. We solve each of those pieces. All right, let's flip the page, all right, okay, all right, and let's just go ahead and jump to number 4 here. So let's look at this one. All right, so sometimes it might require a little bit more, all right, work. So notice here, this is 5x squared equals to 0, all right, because that's one term, so that could be 0. X plus 2 could be equal to 0. X minus 4 could be equal to 0, all right? And so now we solve those. So now sometimes we have to do additional steps. So notice here we would have to divide by 5 first, and that means x squared is equal to 0. And then we would take the square root of both sides, and that would give me 0. So sometimes you might have to do an additional step or two. Here we just get x equals -2. Here we get x equals 4. All right, and that's all finished. Okay, so now, what if it's not in factored form? What do we do? All right, well, we factor it. All right, so we go. All right, so now looking at number 5 here, looking at number 5. Now, if there's two terms, all right, if there's two terms, what we want to do is look for a GCF first, because sometimes you can get a GCF and that gets it right into the factored form, especially if you have a variable as part of that GCF. So notice when I look here, all right, this is a 1 and this is a 4. So the number that goes into 1 and 4, the biggest number I can divide into 1 and 4 is in fact 1. Now, how many x's, all right, do they have in common? Okay, 1, so I can factor out an x. Now, notice what that means. What do I have left? All right, I had 1x, I took out 1x, I have 1x left. All right, I had 1x, I took out 1x, I have the -4 left. And so notice by factoring out this GCF, it's now in factored form. Okay, now here's how you know it's in factored form. All of your factors are linear, okay? None of them, all right, okay, all right, okay, have a higher power than 1 for x. And now it means I can just take each of those pieces and set them equal to 0. So x is equal to 0, and then x minus 4 is equal to 0. All right, and then I don't have to solve this one. I can solve this one. I know x is equal to 4, all right, and I'm finished. Okay, that's it. All right, let's look at 6. All right, so now notice when I look at 6, all right, now, all right, I can see that, yep, I can divide everything by 2. So 2 is common to 2, 4, and 6. I can see that there's a variable common to everything, so I can take out an x. All right, so now, all right, I have to figure out what's left. So 2 divided by 2 is 1. I had x cubed. I took out 1x. I'm left with 1x squared. 4 divided by 2 is 2. I had 2 x's, I took out 1, I have 1 left. And then I have -6 divided by 2 is -3. I had 1x, I took out 1x, I have none left. So now here's what you have to do. Now you have to recognize, oh, this is, all right, kind of like the opener. So now what this means is once you factor out that GCF, now I have to do my area model, all right, to factor this guy. All right, so I'm just going to come down here, all right, and just go through our area model. All right, so we know the A term goes in the upper left, C term in the lower right. Okay, we multiply the A and the C term, so that's -3. And then we have to add to be the B term, which is 2x. All right, and so now what multiplies to be -3 and add to be +2? That would be 3 and -1. And then 3x and -1x. So there's 3x, there's -1x, just like that. All right, so now I can look here. All right, I factor out an x, that's the common factor there. When I look at my next column, I can see that I can factor out a 3. All right, 3 divided by 3 is 1 for both of those. All right, now when I go to my first row, all right, nothing bigger than 1. They have an x in common. When I look at my second row here, they're both negative, so I'm going to take that negative out, and the biggest number I can divide into 1 and 3 is 1. All right, so now here are my factors. So now I'm going to go back up and replace this. So this is 0 equals 2x. And I have to replace this with x plus 3 and x minus 1. So now it's completely factored. And so now it goes back to kind of like what we did up here in number 4. I want to take each of those pieces and set them equal to 0. All right, so 2x could be 0. X plus 3 could be 0. X minus 1 could be 0. And I want to solve all 3 of those. Okay, 2 times what is 0? That would be 0. What plus 3 is 0? That would be -3. All right, what minus 1 is 0? All right, that would be +1. All right, and then that's how you go through the problem. All right, so GCF first, area model second. Okay, all right, so now let's jump over to the next page, and I want to show you something that's a little bit different. All right, so let's look at problem 9 here. Problem 9. Let me get the camera up there. There we go. Okay, so notice here's where we have to do additional work sometimes, because notice to solve a problem, and we've done this all year, okay, to solve a problem, we need it to be equal to 0. All right, so if it's not equal to 0, so notice everything we looked at over here, it was already equal to 0, equal to 0, equal to 0, equal to 0, right? Equal to 0, equal to 0, which means then we can jump right into, all right, looking for a GCF, our factoring process. Now, if it's not equal to 0, that's the first thing you have to do. All right, so now I need to get this equal to 0. Now, we're just going to use the same process we've done all year. To get things equal to 0, we do the opposite. So since this is negative 63, I'm going to add 63. All right, and that's going to make that equal to 0. Then I have to add 63 to the other side. Now, notice, once again, we got to follow our rules for like terms. There are no constants on the left side. So I'm going to just put that right here. So there are no like terms to combine when I add 63 to the left side. So I'm going to bring everything down. 7m squared plus 42m plus 63 is equal to 0. All right, sorry, I had to pause the video and sneeze there. Sorry. Now it's equal to 0. And so now we go back to what we just did. So we're going to look for our GCF first. All right, then we want to try to do our area model and factor. So when I look here, they don't have any variables in common. All right, and then when I look, my smallest coefficient is 7. So I really only have one choice for a coefficient, which is 7. And 7 is a factor of 42 and 73, or 63. So let's take that 7 out. And so I'm left with m squared plus 6m plus 9 is equal to 0. All right, so now what I want to do, all right, okay, is, all right, use my area model here. So I'm going to take my area model right here, all right. Okay, so A term upper left, C term lower right. I have to multiply here. I kind of made that a little bit smaller area than I thought. So 1 times 9 is 9. Then I have to add to be my B term, which is 6m. So I have to find two things that multiply to be 9 and add to be 6, which would be 3 times 3, and then 3m and 3m. So I'm just going to drop those in like that. All right, looking at my first column here, they have an m in common. Looking at my second column, they have a 3 in common. And then when I look at my first row here, they have an m in common, and then I have another 3 in common here. All right, so now this is 7 times, and I get m plus 3 times m plus 3 is equal to 0. All right, now, here's where you have to use a little bit of common sense. I take all of these things could be 0. Now, if this is just a constant, doesn't have a variable, can 7 equal to 0? No, so I don't have to worry about that part. So if it's just a constant as your GCF, you don't have to worry about that. But then I take everything else, right? So m plus 3 is equal to 0, m plus 3 is equal to 0. And notice I get negative 3 twice. And what we say is it's a multiplicity of 2, all right? Multiplicity of 2. So if you get more than one solution, you only have to write it once, but it does tie into some things that you're going to talk about in Algebra 2 eventually. All right, let's do one more together. Let's look at number 11 here. All right, so now, once again, we want it to be equal to 0 before we begin. All right, so when I look at this problem, right, not equal to 0. So I'm going to move my terms on the right side, get it equal to 0. So I'm going to add 4, and then notice there's no constants over here, so I'm going to just make its own column. And then I'm going to subtract 3x squared. Or 3, that should be both m, sorry about that. We'll just say that's an m, 3m squared. I'll make that an m there. All right, and so that's 6m squared plus 14m plus 4 is equal to 0. All right, so now it's equal to 0. So now I'm going to go for my GCF. All right, I can look here. 4 is my smallest coefficient, so I really only have two choices, either 4 or 2. All right, so 4 doesn't go into 14 or 6, but 2 does, so I'm going to factor out a 2. And that gives me 3m squared plus 7m plus 2 is equal to 0. All right, so I'm going to come right over here to my area model. All right, A term goes in the upper left, C term in the lower right. All right, I have to multiply to be 6, and then I have to add to be that B term, which is now 7m. All right, so what multiplies to 6 and adds to 7 would be 6 times 1. So 6m and 1m. Let's just drop those guys in like that. All right, so now when I look at my first column, I can see that they have an M in common. When I look at my second column, they have just a 2 in common. All right, now when I look at this, I have a 3M, all right, in common, and then I just have a 1. So there are my factors. So I get 2, and then I get M plus 2 times 3M plus 1 equals a 0. Now, once again, when I look at things, 2 equals 0, that's not possible, so I can just move on. So M plus 2 could be 0, and 3M plus 1 could be 0. All right, so now looking at this, what plus 2 is 0? That's got to be negative 2. Now, remember what I said earlier, sometimes you have to do more than one step. So when I look here, right, now, what plus 1 is 0? Negative 1. So that means 3M is equal to negative 1, and then I can divide by 3. And you can write your answer as a fraction, so like negative 1/3, or you can convert it to a decimal like negative 0.33. All right, either one is acceptable. All right, so I'm going to wrap up our lesson with that problem. All right, hopefully it seems familiar to you. All right, if you have any questions, all right, make sure you bring those in, highlight any problems that you did not understand, and we will discuss those in class. See ya.